Welcome back. CSEC Chemistry, June 2022, Paper 2, Solutions for Questions 4 to 6. Subscribe and share. Let's begin. Question 4. Figure 5 shows a line diagram representing the electrolytic cell used in the electrolysis of aqueous copper 2 sulfate solution using copper electrodes. A. Part 1. State whether the electrodes used are active or inert. Give a reason for your answer. The electrodes are active because they are made of the same type of metal, copper, present in the electrolyte and takes part in the chemical reaction. Part 2. Describe what occurs at the cathode and anode in an electrolytic cell. At the cathode, reduction reaction occurs since the cation gains electrons. However, at the anode, oxidation reaction occurs since the anion loses electrons. Part 3. State which electrode in Figure 5 on page 16 is the cathode and which electrode is the anode. Electrode A has a positive charge, therefore it is the anode, while electrode B has a negative charge, this is the cathode. B. Part 1. Identify the ions that will migrate to the cathode and anode. The solution is aqueous copper 2 sulfate. Cations having a positive charge move towards the cathode. Since the solution is aqueous copper 2 sulfate, the cations that migrate to the cathode are copper 2 plus and hydrogen plus. Anions are negatively charged ions that move towards the anode. Therefore, the ions that move towards the anode in aqueous copper 2 sulfate are sulfate, SO4 2- and hydroxide ions, OH-. Part 2. Write half equations to show the substances produced at the cathode and the anode. At the cathode, copper 2 plus cations aqueous plus 2 electrons to produce copper metal solid. At the anode, hydroxide ion OH- aqueous produces water H2O liquid plus oxygen gas O2 plus 4 electrons. This equation is not balanced since there is one hydrogen on the reactant side while 2 hydrogens on the product side. Also, there is one oxygen on the reactant side, whereas 3 oxygens on the product side. In order to balance this equation, we will write the numeral or coefficient 4 in front of the hydroxide ions and 2 in front of the water molecule. C. Part 1. Using your answer in Part B2, explain why a redox reaction took place during the electrolysis of the copper 2 sulfate. Redox took place because copper was reduced since the ion gained electrons to form a solid. Also, the oxidation number for copper decreased from +2 to 0. Part 2. Suggest one change that is likely to be observed at the cathode. The cathode will get bigger in size since the copper 2+ ions move towards the cathode, gained electrons to form solid copper which stick to the cathode. D. Explain how the electrolytic cell can be modified to plate copper onto a piece of steel. The electrolytic cell can be modified by replacing the copper cathode with a small piece of steel. The anode will be a pure copper wire. When the circuit is closed, copper cations move towards the steel, which is the cathode, forming solid copper particles which deposit on the surface of the steel. Question 5. A. Part 1. State 4 general characteristics of a homologous series. 1. Same general formula. 2. Same functional group. 3. Same chemical properties. 4. Members have a common general method of preparation. Here's another one. 5. Same last name ending. Part 2. Write the general formula of the alcohol homologous series and the molecular formula of the fifth member of the homologous series. The general formula will be CnH2n+1OH. Since we are writing the molecular formula of the fifth member, N = 5. The adjusted formula will be C5H2 multiplied by 5 plus 1 OH. C5H10 plus 1 OH. The molecular formula will be C5H11OH. B. Figure 6 shows the fully displayed structure of compound D. Circle any two functional groups shown in this structure. We can circle the C double bond O OH since this is a carboxyl group, the C double bond C since this is alkene double bond, or you could even circle C double bond O attached to single bond O since this is an ester linkage, or you could circle C single bond C for the alkane. C. Experiments were carried out on 2 hydrocarbon gas samples, E and F, to determine which gas is ethane and which gas is ethene. Table 4 presents the experiment and observations. For the experiment, each hydrocarbon was bubbled through bromine water. The observation for hydrocarbon E is orange bromine water becomes colorless, while for hydrocarbon F, no reaction. Part 1. State the difference between alkanes and alkenes. Alkanes are saturated, meaning they only contain single bonds and are less reactive than alkenes. However, alkenes are unsaturated, meaning they contain double bond or double bonds between carbon atoms and are more reactive than alkanes. Part 2. Using the observations in Table 4, identify hydrocarbons E and F. Hydrocarbon E would be alkene, while hydrocarbon F is alkane. Part 3. State the conditions under which an alkane would react with bromine. Alkanes react with bromine in the presence of ultraviolet UV light. Part 4. Write a balanced chemical equation including state symbols for the burning of ethene gas in air. Ethene C2H4 gas plus oxygen O2 gas produce carbon dioxide CO2 gas plus water H2O gas. This equation is not balanced since there are 4 hydrogens on the reactant side while 2 hydrogens on the product side. There are 2 carbons on the reactant side while 1 carbon on the product side. Also, there are 2 oxygens on the reactant side while 3 oxygens on the product side. In order to balance this equation, we will write the numeral or coefficient 3 in front of the oxygen, 2 in front of the carbon dioxide, and 2 in front of the water. Question 6. A. A chemical factory produces pesticides, fertilizers, and plastics using synthetic raw materials. The factory has been in operation for the past 5 years and is located near agricultural lands in a small rural community. Recently, the residents of the community have reported significant loss in plant and animal life due to increases in air pollutants, non-biodegradable solid waste, and algal growth in the nearby waterways. The increased toxicity has impacted the local agricultural economy. Part 1. State 2 examples of air pollutants. Examples include carbon monoxide, CO, nitrogen dioxide, NO2, sulfur dioxide, SO2, and nitric oxide, NO. Part 2. Suggest 3 substances found in the products produced by the chemical factory that may have contributed to the increased algal growth in the waterways. Substances include nitrates, phosphates, and sulfates. B. Part 1. Define the term green chemistry. Green chemistry is the design and use of chemical products and processes which decrease or eliminate harmful substances that damage health and the environment. Part 2. List 3 principles of green chemistry. 1. Prevent waste. 2. Analyze in real time to prevent pollution. 3. Use safer solvents and reaction conditions. Here's another one. 4. Design for degradation. Part 3. Explain how any 3 principles of green chemistry can be used by the factory to minimize the impact of pollution on the local agricultural economy. 3 principles factories can use to minimize the impact of pollution on agriculture are: using renewable energy. Renewable energy from the sun can be used to power factories. This would decrease air pollution since non-renewable energy resources release harmful greenhouse gases, leading to global warming. Also, high temperatures cause many plant death. Second principle: analyze chemicals and machines to prevent pollution. Factories can analyze wastes that pollute water sources like river, resulting in death of animals. After analysis, factories can partner with water treatment plants to treat the wastewater, reducing the contaminants. Third principle: prevent waste. Factories can use other raw materials that produce less or no waste, like sulfur dioxide, during production. This compound contributes to acid rain, which damages plant leaves and lowers plant growth. This is the end of question 6. Subscribe and share for upcoming content. Thanks for watching. All the best.